In this mentoring session, we will take a first look at IPv4 subnetting.
Yes, I hear you.
Okay.
Can you hear me?
Yeah, I hear you.
Okay.
Okay. So basically, the subnet masks, right, tells you which portion of the address is the network portion and which part of it is the host portion. And the host is anything you have on your network, like your laptop, your cell phone, your IP camera, right? Streaming device, those are all hosts, right? And what this guy says here, right here, tells you the maximum number of hosts is that's like 16 million, right? See that right there?
Yeah.
16 million. That's a lot. Okay, that's a lot.
That can connect to that, man.
Well, potentially, but your hardware wouldn't probably be able. Your stuff in your house couldn't handle it. That's 16 million, different devices you'd have to keep track of and send packets back and forth. That wouldn't happen. That wouldn't work, right? And so you start to say, man, that doesn't make much sense, right? But in my article that I wrote, right, I said this is a massive number of hosts within that single network, right? Massive. I use the word massive. It is, and so by definition, though, a Class A has this mask, right? This all ones, and basically what it's doing, right? If you look down here with the zeros and ones, I'm going to explain how we get around that problem, right? If you look down here, you see these all ones. They effectively, what they do is they create what they call a logical and so it ends up that it will show the network to the routing device and to your local connected devices. They only see this portion of it, the last 3 octets, right? And the reason why we call it octets is because there's 8. If you count these guys, it's 4 and 4 is 8. Ones are zeros, right? That's why you hear me. There's an octet. There's 8 of them, right? A quartet is 4, an octet is 8. Like music.
Yeah.
All right. So, right here, wherever there's ones, that's what the routing device sees, and then where the zeros is what the connected devices see, right? Your hosts, this stuff here, and it's way too much. And so, this is like something I will definitely post on private IP addresses. All right. There's a bunch of private IP addresses. This one here is my favorite because it's the simplest one, right? But they all have one thing in common. They have a 24-bit. Instead of an 8 bits, it's going to be 24 bits. So we click the slider here until we get to 24. And notice when it gets to 24 how things kind of even out a little bit, right? You got this 255, 255. Well, that 255 really happens because of the way this is binary. I mean, you've heard that word, right? Binary?
Yes.
Okay. So the way binary works is, and I can bring up right now I'm just like, let's see if I can bring my calculator into that screen. And I can show you how binary works. Let me open up my calculator. Just a regular old calculator, all right? I'm gonna see if I can fit it in there. It's kind of huge, but I'm gonna fit it in there. Although you'll see my whole screen. And in fact, you know what? Since you can see my whole screen, but the recording is not. So I'm gonna put this right on top of this, right? And I'm just going to have standard. So basically, the way it works is this. A 1 is in the first place is equal to a 1. A 1 in the second place is equal to a 2. So 1, 1 in binary is 3. Okay? And then another space, you're going to double it, so it's be a 4. So it's going to be 4 plus 2 is 6, and this is 7. So binary is 7, is 3 1s, okay? And I'm going to put one more in there and see if I can keep track of it. So we put one more in here, right? Ignore this would be, this is 1, 2, and 4, and 8, right? So it would be 8 plus 7. You see that?
Yeah.
And so now 8 plus 7, and terrible me in the math, man, but basically it's 15, all right?
Yes.
Now this keeps on like this for a while, and what it rounds out to be, and let me see if I can get my calculator to us. Let's see if we have it here, because sometimes they do have this in a scientific. We got scientific and we got programmer. I'm thinking it's in the programmer. Yeah, it's in programmer. And we're going to go to binary. Okay. And I'm going to pull it back in the screen so we can actually see that. Notice in the binary setup, right, all you see there, the other buttons are grayed out. All you got is 1 and 0. Okay. So if I basically do like that and just keep on going, he maxes out here. Let me just see how far we'll go with this. Okay, and so that's the next range. Keep on going with the ones. Okay, right? You see right here the decimal equivalent of it. You see that?
First 3 numbers.
Okay, so I'm gonna back it out a little bit. I'm gonna back it out. All right, so 4 1s is 15, like I said, right?
Yeah.
See, and there it is. It's equal to the number 15. If I add another 1, okay, all of a sudden it's 31, because that is 15 plus 16.
Yeah.
It's 31. Okay, you see how that works? And so you add another 1, that's 63. You add another 1, that's 127, and at the final one, that's 255. Okay, so I hold this off to the side. Okay, hold this off to the side, and the thing is, and I'm gonna start a new recording of the screen and capture the whole screen in a second. I think that's probably best. Let me stop this recording. Let's see what happens.
We lost this portion of our live session, so let me explain IPv4 private IP space, the need for it, how it can be subnetted, and the role of classless inter-domain routing, CIDR. IPv4 private IP space is a set of IP address ranges reserved for use in private networks. I will explain its purpose, how it's used, and how it relates to subnetting and CIDR. There are 3 blocks of private IP spaces. They are: first, a single Class A network, 10.0.0.0 to 10.255.255.255, 10.0.0.0/8. Then, 16 contiguous Class B networks, 172.16.0.0 to 172.31.255.255, 172.16.0.0/12. And finally, 256 contiguous Class C networks, 192.168.0.0 to 192.168.255.255, 192.168.0.0/16. Using the Boson IP subnet calculator shown earlier, you can examine the 3 blocks of private IPv4 address spaces for Class A, Class B, and Class C. Private network addresses are not allocated to any specific organization. Anyone can use these addresses without approval from regional or local internet registries. Private IP address spaces were originally defined to assist in delaying IPv4 address use depletion. IP packets originating from or addressed to a private IP address cannot be routed through the public internet. Private addresses are often seen as enhancing network security for the internal network, since use of private addresses internally makes it difficult for an external host to initiate a connection to an internal system. The use of private IP addresses also give us flexibility in network design and management. Subnetting. Private IP ranges can be subnet to create smaller network segments. This allows for better network organization, improved traffic management, enhanced security through network segmentation. Classless interdomain routing, CIDR. CIDR is a method for allocating IP addresses and routing IP packets. CIDR replaced the older classful network addressing. It allows for more efficient use of IP address space. It enables flexible subnet mask lengths. CIDR and private IP space. CIDR notation / is used to represent private IP ranges and their subnets. For example, 10.0.0.0/8 represents the entire 10.x.x.x private range. 192.168.1.0/24 represents a subnet of 256 addresses in the 192.168.x.x range. So there you have it. Let's recap. IPv4 private IP space consists of reserved address ranges for use in private networks. It's crucial for conserving public IP addresses, enhancing network security, and providing flexibility in network design. These private ranges can be subnet to create smaller network segments, allowing for better organization, traffic management, and security. Classless interdomain routing, CIDR, is a method for allocating IP addresses and routing that replaced the older classful system. It enables more efficient use of IP address space and flexible subnet mask lengths. CIDR notation is commonly used to represent both private IP ranges and their subnets, providing a concise way to describe network address allocations. Together, private IP space, subnetting, and CIDR form the backbone of modern internal network design and management, allowing organizations to create complex, secure, and efficient network infrastructures. That's a wrap. Until next time, this is Functionkey.